Write each fraction as a percent. The way that we do it in my class is we create an equivalent fraction out of 100 because percent means per 100. Then we cross multiply. So 3 times 100 is 300 and divide by the number we haven't used yet. 300 divided by 30 is 10, so this would be 10%. We use this setup of part, whole, and then we say it equals the percent out of 100. So that numerator would be 10 or 10%. Here we have two histograms. It says staff and students, middle school staff, middle school students, were surveyed about the number of hours they spent outdoors last week. The results are summarized in these two histograms. Do they have the same scales? Well, they both have a frequency that counts by fives, and their intervals count by twos, 2, 4, 6, 8, 10, and so on. Do you think using the same scale is helpful when comparing two data distributions? Well, yeah, using that same scale is helpful because then we can compare each individual section to the other section for the other group. How are these two similar? They are both skewed right. There's long extended off towards the right direction. But you can see that there were many more middle school students than there were staff. If we were asked the statistical question, who typically spent more time outdoors last week, a middle school student or a middle school staff member, can we tell which group typically spent more time? Well, it's hard to tell because this one is taller because there were more students than staff members. But if we were to compare maybe their medians or their averages, we might be able to look at which one spent more time without being impacted by how many students there were. So today we're going to use a different type of data distribution. Instead of just a histogram, we're going to use a relative frequency histogram to help us compare percentages of students and staff. Let's read through 1A. Staff and students at a middle school were surveyed about the number of hours they spent outdoors last week. The results are shown in the following frequency tables. A. Complete the relative frequency column for each data distribution. Write the relative frequency as a decimal and a percent. To do this, we need to figure out how many total students were surveyed. So we are going to add all these values to get the total. And there are 200 altogether. So 200 students were surveyed. To find the relative frequency, we're going to write 28 out of 200. That's the fraction version, but it asks us for the decimal and the percent. So if we divide 28 by 200, that gives us a decimal of 0.14, which is the same as 14%. We move that decimal 2 spots to the right to turn it into a percent. This next one would be 44 out of 200. So to get the decimal, 44 divided by 200 is 0.22 or 22%. 42 out of 200. 42 divided by 200 is 0.21 or 21%. We'll continue doing this for the rest of the table. This is for the students. The next section will be for the staff. Again, we need to find the total of all staff members. So 7 plus 6 plus 3 plus 4 plus 2 plus 1 plus 1 plus 1 plus the 2 zeros gives us a total of 25 staff members. So to find the frequency here, we're going to do 7 out of 25. And 7 divided by 25 is 0.28 or 28%. Next one would be 6 out of 25, which comes out to 0.24 or 24%. 3 out of 25 is 0.12, which is rewritten as 12%. Two out of 25 is 0.08, which is 8%. 1 out of 25 is 0.04 or 4%. These are the same. And we have 0 out of 25 is 0 or 0%. And again, 0 or 0%. So create a relative frequency histogram for each data distribution. We're going to use these decimals as the heights, or these percents as the heights on our relative frequency histogram. So from 0 to 2, we're going to go up to 0.28. Which would be just under 0.3. Then we would use the next decimal. Then the next decimal we had was 0.24. So right under 0.25. And these on a histogram are touching. Then 0.12. Which is under 15 and over 10. Then we had 0.16, which is just above 15. 0.08, slightly under 10. 0.04, and there were 3 of those. Right under 0.05. And then the rest were 0. We need to do the same thing for the students, using the decimals from the student's histogram, or student's relative frequency, to build the histogram. So there are the two histograms, one for the students and one for the staff. These ones are based on the relative frequencies, so that way it's comparing the decimals rather than how many students and how many staff. More of a percentage. Make sure you get these sketched out. Remember, the bars should be touching in a histogram. They do not touch in a bar graph, but in a histogram they do. Then we're going to use these two histograms to answer some additional questions. C says to use the relative frequency histogram to describe the center, shape, and spread of the student's data distribution. The center is between 4 to 6. You can see there's a big chunk of data here, and then it gets fewer and fewer as we go out. So that interval here would represent the center. The shape is skewed right because it extends farther to the right from the center. And the range, it's between 0 and 20, but it could be as low as 16 if it was at 2 and 18, because remember, these are intervals, they're not exact values, so it could be between 16 and 20. Then part D asks us to do pretty much the same thing, but for the staff. This one, the center is between 2 and 4. These data values here are higher. The shape is also skewed right. And in this one, the range is between 16 and 12, so 12 to 16. Then part E, how many middle school students spent less than 10 hours outdoors last week? For this one, we would use the regular frequency instead of the relative frequency. So let's go back and look at how many students spent less than 10 hours outdoors. Here is the up to 10 hours. So we want all of these students spent less than 10 hours. So we're going to add these values up. 28 plus 44 plus 42 plus 26 plus 16 is a total of 156 students who spent less than 10 hours outdoors. Then in F, it asks what percent of middle school students spent less than 10 hours outdoors last week. So remember, there were 200 students altogether. 156 out of 200 is 0.78, which is 78% of the students spent less than 10 hours outside last week. How many middle school staff members spent less than 10 hours outdoors last week? Here is up to 10. So if we add those together, 7 plus 6 plus 3 plus 4 plus 2 is 22 staff members. H, what percent of the staff members spent less than 10 hours? There were 25 total staff members, so 22 out of 25 is 0.88, which is 88%. Based on the information in the relative frequency histogram, did the students or staff members typically spend more time outdoors last week? Explain. Well, the students typically spent more time outdoors. You can see that 78% spent less than 10 hours. However, more of the staff members spent less time outside. But the students typically spend more time outdoors. If we were to change this way that it's written, instead of saying 78% spent less than 10 hours, that would mean 22% of the students spent more time, because 22 plus 78 makes 100. But 88 plus 12 makes 100. So, and only 12% spend more than 10 hours outside. So more students spent more time outside. The ages of participants in a recent fundraiser are recorded in the following tables and relative frequency histograms. Participants completed either a 5-kilometer run or a 15-kilometer run. So here are the 5-kilometer run participants and their relative frequencies. And then the 15-kilometer run with their participants' ages and their relative frequencies. They've displayed that data in the histogram for the 5-kilometer and for the 15 kilometers. A. Describe the center, shape, and spread of each data distribution. We can see here that the center is around 30 to 40 for the 5-kilometer run, as well as for the 15-kilometer run. They are both approximately symmetric. The spread is between 60 from 10 to 70, that's 60, but it could be as low as 40 from 20 to 60. So between 40 and 60 years old, and that is true for both. B. What percent of the 5-kilometer run participants are 50 years old or older? Well, for 50 years old or older, it would be these two sections or these two intervals. Which would we add those two? 0.5 and 0.5 is 0.10, which is the same as 10%. C. What percent of the 15-kilometer run participants are 50 years old or older? That would be this interval here. 14 plus 6 is 20. So 0.20 turns into 20%. D. Which run had more participants who were 50 years old or older? Explain. The 5-kilometer run had 20. There's 10 and 10. The 15-kilometer run had 10. E. Which run had a greater percentage of participants who were 50 years old or older? Well, we had 20 of the 5-kilometer race and 10 of the 15-kilometer race, but we have to compare that to how many altogether in the races. If we add up the frequencies, that tells us how many participants. So this would be the frequencies for the 15-kilometer and add up all the frequencies for the 5-kilometer. Now we need to change them to decimals. 20 out of 200 is 0.1, which is 10%, and 10 out of 50 is 0.2, which is 20%. So the 15-kilometer had more. The box plot summarizes the number of hours middle school staff and students spent outdoors last week. We're going to use these two data distributions to help us answer parts A through G. A says, state the 5-number summary values for the student data distribution. Our minimum is 0. Q1 lines up at 2. The median is at 5. Q3 is at 9. And the maximum is at 19. Then part B asks us to state the 5-number summary for the staff data distribution. The minimum is at 0. Q1 is at 1. The median lines up at 3. Q3 is at 6. And the maximum is at 14. Make sure you have the 5-number summary for both the staff and the students, or students and staff, written down in parts A and B. C. Compare the medians of the data distributions. What do the medians tell you about the typical amount of time these middle school students and staff members spent outdoors? Here are the medians. The student median is 5 and the staff median is 3. The median splits the data in the middle. So half of our students spend less than 5 hours outside, and half of our students spend more than 5 hours outside. Half of the staff spends less than 3 hours outside, and half of the staff spends more than 3 hours outside. D. Compare the interquartile ranges of the data distribution. What do the interquartile ranges tell you about the spread of the times these middle school students and staff members spent outdoors? To find the interquartile range, also known as IQR, we take Q3 and subtract Q1. So for the students, 9 minus 2 is 7, and for the staff, 6 minus 1 is 5. The interquartile range tells us about the middle half, or the middle 50%. So the middle 50% of the students had a spread of 7 hours, and the middle 50% of the staff had a spread of 5 hours. E. Which group had the person who spent the most time outdoors last week? And how many hours did this person spend outdoors last week? The students had a higher maximum at 19. So we know that the students spent, or one of the students spent 19 hours outdoors last week. F. Compare the lowest quartile of each data distribution. What does this tell us about the amount of time these middle school students and staff members spent outdoors? Q1 for the students is at 2, and Q1 for the staff is at 1. This means that about a quarter of the students spent at most 2 hours outside, and a quarter of the staff spent at most 1 hour outside. G. Based on the information in the box plots, did students and staff members typically spend the same amount of time outdoors last week? Explain. Well, no, the students spent more time outdoors last week. Their first quartile, median, and maximums were all higher than the staff's box plots. The box plot display the data distributions for the ages of participants in a recent fundraiser. Participants ran distances of either 5 kilometers or 15 kilometers. A says which data distribution has a greater median. Well, the median line in the 15 kilometers is higher. The 15 kilometer has a greater median at 36, whereas the 5 kilometer race has a median of 35. Which data distribution has a greater interquartile range? The IQR is from Q3 to Q1, and we subtract to find the difference. So the IQR is greater in the 15 kilometer. It's more spread out. It has an IQR of 21. Q1 is at 27 and Q3 is at 48. But in the 5-kilometer race, Q1 is at 30 and Q3 is at 41. So it only has an IQR of 11. And which data distribution has a lesser range? The range goes from the min to the max. The interquartile range is from Q1 to Q3. So the 5-kilometer race has the lower range. The maximum was at 63 and the minimum was at 16, which gives us a difference of 47. In the 15-kilometer race, the maximum was 68 and the minimum was at 15, which is a range of 53. Which data distribution has the oldest runner, and how old is that runner? The maximum represents the runner. So the data distribution with the oldest runner is the 15-kilometer race, and that runner is at 68 years old. Based on the information from the box plot, which run appears to have attracted a greater spread of ages? Explain. Well, the 15-kilometer race has a greater range and a greater IQR. So the 15-kilometer race has attracted a greater spread. If it has greater range and greater IQR, that's more variability. So a bigger spread. And that takes care of lesson 19. We will pick up in the next lesson in the next video.